we are going to learn representation of a discrete signal, which is the next part of digital signal and image processing. There are three types of signal representation: graphical representation, sequential representation, and functional representation. So we are first starting from graphical representation. In graphical representation, each signal is represented separately. See in first example, x of minus 2 is equal to 2, x of minus 1 is equal to 3, x of 0 is equal to 1, and x of 1 is equal to 1, x of 2 is equal to 2. See the graph. This is x-axis, this is y-axis. X-axis represented number of functions and x of n is a function. So value of x of n is varies from 0 to infinity. Value of x of minus 2 means value of n is minus 2. 0, minus 1, minus 2, and a value of n is minus 2, and value of x of n, that is x of minus 2. X of minus 2 is 2. This is 2. Then next is x of minus 1 is equal to 3. Value of n is minus 1, and value of x of n is 3. Then x of 0. Value of n is 0, and x of 0 is 0. Next, x of 1. Value of n is 1, and value of x of n is 1. X of 2 is equal to 2. Value of n is 2, and x of 2 is 2. So this is a simple graphical representation of discrete time signal. Then the next is sequential signal. In sequential signal, the signal is represented in a particular sequence, and the sequence is start from where the arrow is given. So here the sequence is 0, 1, 2, 0, 2, 1, and the arrow is given at this 0. That means what? We have to start at a signal from this point. This point is 0. That means value of n is 0. Then value of n is 1. Value of n is 2. Here value of n is minus 1. Value of n is minus 2. Value of n is minus 3. So value of 0 is 0. This one. Value of 1 is minus plus 2. Value of 1 is plus 2. Value of 2 is 1. Value of 2 is 1. Again, value of minus 1 is 2. Minus 1 is 2. Minus 2 is 1. Minus 2 is 1. And minus 3 is 0. Minus 3 is 0. So this is a sequential representation of a signal. Then next is functional representation. In functional representation, x of n is given in a particular function, like that x of n is equal to 1 for n belongs to 1, 2, 3. Then x of n is equal to minus 3 for n belongs to minus 1 and 0, and x of n is 0 for elsewhere. Means what? For other signal, value of x of n is, or value of n is 0. So first, x of n is 1. For what? N is 1, 2, 3. For value of n is 1, 2, 3. Value of x of n is 1. This is 1, 1, 1. Next, value of x of n is minus 3. For n belongs to minus 1 and 0. For 0, minus 3. For minus 1, minus 3. And value of x of n is 0 for elsewhere. That means other signals. This one, this one, this one, and this one. Value of x of n is 0. So this is a functional representation, this is sequential, and this is graphical. So these two examples are for your work. So x of n is equal to 0, 0, 5, 2, 1, 0, 2, 3, and x of n is equal to minus 1, minus 2 and 0. So now the next part is elementary of discrete time signal. The first is delta or unit impulse function. The delta functions means what? The signal which has only unitary value, or delta, it is represented in delta n. For delta n is equal to 1 for n belongs to 0, and delta n is equal to 0 for other signals. This is a representation. This is x-axis gives the value of n. This is y-axis gives the value of delta n or x of n. The value of delta n is 1 for n is equal to 0. The value of delta n is 1, and for otherwise it is 0, 0, 0. So this is about delta function. It is represented in delta n, and its value is 1 for 0, and for other points its value is 0. The next is unit step signal. Unit step signal means what? It is denoted by u of n. For 1 unit, u of n is equal to 1 for n is greater than or equal to 0, and u of n is equal to 0 for otherwise. Means what? Value of u of n is 1 for n. Value of n is greater than equal to 0, and it's 0 for otherwise. Means what? Your graph is represented by, this is x-axis represented by n, and this is y-axis represented by x of n or u of n. What the function tells? Value of u of n is 1 for n is greater than or equal to 0. That means what? Value of n is greater than or equal to 0, and all the function which are less than 0, that is minus 1, minus 2, minus 3, the value is 0, and only the function which are greater than 0, the value is 1. That is this function, 3, then 4, 5, and so on. Value is 1, and for non-zero, less than 0, the value is 0. It's called as unit step signal. The third is unit ramp signal. Unit ramp signal, which is denoted by u of r n, and it is defined as n is equal to, u of n is equal to n for n is greater than or equal to 0, and it is 0 for otherwise. See the map. What is the unit ramp signal? U of r of n. Value of n is greater than or equal to 0. Also, u of n is equal to n. That means value of n on x-axis and value of n on ur of n both are same. That is, signal are increase in particular range. See, first we can take value of n is equal to 0. X is greater than or equal to 0. The signal is this point. Then put value of n is equal to u r of n. Value of n is equal to 1, and n is greater than or equal to 0. N is equal to 1. This also 1, which is greater than or equal to 0. This one, n is 1, and u r of n, which is also 1, this signal. Next, n is equal to 2. N is greater than equal to 0, that is 2 is greater than or equal to 0. That is value of n is 2, value of UR of n is 2. Then n is equal to 3. 3 is greater than or equal to 0. Therefore n is 3, UR of n is also 3. Same for 4 and so on. That is, the signal is incremented in particular range. Hence it is called as unit ramp function. The next is exponential signal. For this exponential signal, where the function x of n is equal to a raised to n for all n. Means what? Here the signal is incremented or decremented exponentially. Here there are 4 conditions for exponential function. The first is a is less than 1 or greater than 0. That is, a is between 0 to 1. The second condition is a is greater than 1. Third condition is a is between -1 to 0. That means a is greater than -1 but less than 0. And fourth condition is a is less than -1. So these are the 4 conditions for exponential function. The first is a is between 0 to 1. The second is a is greater than 1. Third is a is between -1 to 0. And fourth is a is less than 1. That means the value of a means what? Value of signal. Then next is sinusoidal signal. Sinusoidal signals are given by the formula x of n is equal to a cos omega n plus phi, where a is equal to amplitude, omega is equal to frequency in radians, and phi is equal to phase. Okay, a is equal to amplitude, omega is equal to frequency in radian, and phi is equal to phase. Again, value of omega is 2 pi f, which is used in next problems. So this wave is basically represented as a sine wave. This is n, this is x of n, and those are the points. These ones are point which we have to draw. So this is all about elements of discrete time signal. The first is delta signal, second is unit step signal, third is unit ramp signal, fourth is exponential signal, and fifth is sinusoidal signal. So next we are going to classification of discrete time signal. Discrete time signal are classified into 3 categories. First is even and odd signal, which is also called as symmetric and antisymmetric signal. Second is periodic and aperiodic signal. Third is energy and power signal. So first we are going to see even and odd signal. What we can say as even function? Evens means what? Symmetric function. If x of n is equal to x of minus n. The signal is said to be even or symmetric. Second, if x of n is equal to minus of x of minus n, the signal is odd or asymmetric. These are the two conditions we have to remember. First is, for even function, value of x of n is equal to x of minus n. And second, for odd function, value of x of n is equal to x of minus n. Basically what? Even odd functions are simply mirror image of x of n. That means if the value of n is 1, then value of x of n, see x of n is equal to x of minus n, means what? X of 1 is equal to x of minus 1. If x of 1 is equal to 2, then x of minus 1 is also 2. That means if we have given the value of x of 1 is 2, then if we get the value of x of minus 1 is 2, then we can call this as this is symmetric function. Now I will show you on graph. See this graph, right? This is n, this is x of n, this is n, this is x of n. First, value of x of n is equal to value of x of minus n. This is 0, 1, 2, 3. Minus 1, minus 2, minus 3. If value of x of 1 is 1, x of 2 is 1, x of 3 is 1, this is 1. Then if this function is even function, then what? Value of x of n is equal to value of x of minus n. If x of 1 is 1, then x of minus 1 is also 1. X of 2 is 1, then x of minus 2 is 1. X of 3 is 1, then x of minus 3 is also 1. This we can call as a even function. And what is odd function? This is 0, 1, 2, 3. Minus 1, minus 2, minus 3. This is 1. So basically odd function what tell us? If x of n is equal to minus of x of minus n, means what? X of n is equal to minus of x of minus n. If x of n means x of 1 is equal to, x of 1 is equal to what? 1. Then minus of x of minus 1 is also equal to 1. See, is also equal to minus 1. Sorry. This is minus 1. Let's see, First, if we see x of n is equal to 1, x of 2 is equal to 1, x of 3 is equal to 1, then x of 1 is equal to 1, then put n as a minus 1. This x of minus 1 is equal to what? What we can get? Minus 1. This is. Then put n as a x of 2. X of 2, what we get? 1. But here what we can get? Minus of x of minus 2 is what? Minus 1. Here also minus 1. So it is what? It is mirror image. The both are same and both are opposite to each other. So we have to remember the function of x, even function and odd function, which ask in exam. So the even and odd function is get by x e of n is equal to x of n plus x of minus n divided by 2, and x odd of n is equal to x of n plus x of minus of x of n divided by 2. Why? Because x of n is equal to minus of x of minus n. This is the formula for even and odd function. So next is, second is periodic and aperiodic function. See, what is periodic and aperiodic function? Here one formula is there. X of small n plus capital N is equal to x of n, and x of n is equal to a cos omega n plus theta is a periodic function. Where omega is equal to 2 pi f and f is equal to k upon n. So what is k and what is n? Both are integer. But how it can works, which you can get in example. So here we are going to see one example. You have to remember only 2, 1, 2 and 3 things. N means what? Number of samples, and k is a constant. Okay, but both are in integer and both have a ratio. Discrete time signal is periodic only when its frequency is a rational number, that is ratio of two numbers. This is the ratio of two numbers. How it can get? First, see the example. Cos 0.01 pi n. This is one example. So how it can be solved? First, what we have to write? X of n is equal to what? A cos omega n. A cos omega n plus theta. Here value of a is 1, so it is neglected. Value of omega is equal to what? 0.01 pi. Okay, then what is omega? Omega is equal to 2 pi f. Therefore 2 pi f is equal to 0.01 pi. Right? Okay, next, what is f? F is equal to 0.01 pi upon 2 pi. Here pi get cancel, and 0.001 I can write as a 1 upon 200 is equal to f. Right? So what is the formula of f? F is equal to k upon n. It is similar to k upon n. Value of k, that is constant, is 1 and value of n is 2000. N means what? Sample. Number of sample, which is 2000. And this is in the form of ratio, integral ratio. So the answer is, number of samples is 2000. Next, see the next example. X of n is equal to cos 3 pi n. Right? Here x of n is equal to a cos omega pi plus theta. Right? What is the value of omega? 3 pi. omega is equal to 3 pi. Omega is equal to what? 2 pi f is equal to what? 3 pi. F is equal to what? 3 pi upon 2. Right? 3 pi upon 2 pi. These two get cancelled. Answer is 3 by 2. Right? So it is also equal to k upon f. K upon n. Right? F is equal to k upon n. We can get 3 by 2. So value of k is 3 and number of samples is 2. Here the answer is f. Answer n is equal to 2. So I hope you can understand those two questions. First homework is sin 3n. Second homework is cos 0.5 pi n. So I'll see you. The another example is x of n is equal to cos n by 8 into cos pi n by 8. Right? See, here x of n is equal to cos omega 1 n into cos omega 2 n. Right? Omega 1 is equal to what? 1 by 8. And omega 2 is equal to what? Pi by 8. Omega means what? 2 pi f1 is equal to 1 by 8. 2 pi f2 is equal to pi by 8. Therefore, f1 is equal to what? 1 by 8. Right? 2 pi into 8, that is 16 pi. And f2 means what? Pi by 8 into 1 by 2 pi. Pi get cancelled. The answer is 1 by 16. Therefore, f1, this is f2, this is f1 is equal to 1 by 16 pi. See these two ratios. f1 is 1 upon 16 pi and f2 is only 1 upon 16. F is equal to what? K by n. Both k and n have integer. But in first function, 1 is integer but 16 pi is not an integer. Second function, 1 is integer, 16 is integer and both have a particular ratio. So first is non-periodic function, but the second is periodic function. But after getting multiplication of both, we can get non-periodic function. So I hope you understand this problem. So this is work for you. First is sin 3 pi n. Second, cos 0.5 pi n. Third, cos 3 pi by 2 n into cos 5 pi by 8 n. So these three example for your work, and we have to show that periodic or non-periodic or aperiodic. So next is energy and power signal. Energy and power signal we'll see in next lecture.